interest includes the machine learning, deep learning, big data, and soft computing. And the teaching interest in the machine learning, deep learning, big data, and soft computing. He has published uh, 8+ national and international journals, uh, papers in national and international journals, and 50+ papers in international conferences. Today, we take 2 sessions on cyber security. So I once again welcome you, sir, in this 6-day program, refresher induction and refresher program on cybersecurity and autonomy. So, over to you, sir.
Yeah, thank you, Professor Dolly and team, for this great introduction. Though I do not deserve. Yeah, but thank you very much, and thank you, team, for organizing this. Very good, interesting, and I think many participants have given you feedback as well, right? So very interesting FDP program. And very good morning to all the participants attending in this morning, right? Though in most of the places Saturday is declared as holiday, and due to the COVID pandemic, I'm very happy to see these many participants at this point of time. So thank you everyone. So in the today's talk, so I will be just most of you have basically learned about the machine learning and the type of attacks and what type of attacks and what is cyber physical systems and what type of attacks you can see, and from those attacks how can you defend your system, right? So many of the talks, I think in 5 days, recent 5 days, you have observed and you have understood those things. So in this talk, we will be going to little bit briefly, you may see some repetition as well from many of the talks, but I have a slides which basically is a comprehensive slides, right? Which basically covers most of the things. So what are the machine learning, and then how the machine learning basically used in order to design the threat, in order to defend the threat, right? And current state of art is basically, you know, that many people are looking towards the artificial intelligence, machine learning, deep learning models in order to basically defend their systems, mostly the cyber physical system, whether it is a network based attack, whether it is a basically some sort of anomaly based attacks, some sort of malware type of attacks. Because if you see the communication, or you can say the communication through internet, or you can say through the cloud systems, is very prominent nowadays. So everyone has mobile phones, so handheld devices, mobile phones, pads, laptops, right? So most also vulnerability is very popular nowadays, and as we grow in the technology, of course you have to provide the privacy to the users, to the customers, right? So we will be going to discuss few of the basic machine learning model, and then you will be able to know that what is machine learning, and then how the machine learning can design the threat. So if you are a hacker, if you are a hijacker, you can design the threat. And then if you someone has designed the threat, then how your system automatically can defend it. So that is the motivation for the today's talk here. So at any point of time, you may ask questions. So I'm not going to cover the lecture. So I feel and I hope that this talk should be basically discussion based talk, not much the theoretical, or not much just like lecture, right? So this I hope that you people will participate in interaction, and maybe later on in the next session, so we will try to demonstrate one or two of the models, threat models, based on the adversarial examples, and you will see that very good model are under threat, right? So you can design such a system which can basically fool the security system, which can basically bypass the security system, and you should have some model which can defend it, right? So that it can detect that someone is basically spoofing or fooling the security system, right? So I'm just going to share my slides. So So is it visible to all of you? Hello.
Yes, sir, it's visible. It's
Yeah.
visible, sir.
Thank you. So I'm just trying to put in full screen, but sometime in Google Meet, full screen does disable the movement. I'm just trying if it works. Just yeah. So the outline of the today's talk is basically the process involved in. So we will going to define the machine learning first, and then uh, how machine learning works, and what are the basically ingredients in machine learning. Then what type of task machine learning can solve. What type of problem machine learning is basically aimed to solve, and what is the application of machine learning in security, and we will discuss those things. So the first, I think maybe 30 to 40 minutes, we will going to discuss about the machine learning, and how and what are the basically problems that you can solve using the machine learning. Then I think many of you have done the attacks and most of the security things, so you will be able to relate your problem that machine learning can be used in order to solve those problems. Right? Sometime it may solve fully, sometime it may solve partially. So we will discuss those things in the today's discussions. Okay. Uh, then at the end, if time permits, so we will try to give you some demonstration, and we will be happy to have a question. So questions you can ask in between as well. So that it becomes more discussion oriented, not more theoretical oriented. Okay. Uh, so the learning process, if we discuss about the learning process, what is the learning process? And so mostly we have a data. So machine learning model basically works on the data. So you should have a data. So data may be in any form. So it may be data you have received, maybe from cameras, maybe from video feeds. So it may be images, it may be a video, it may be text data. It may be from social media sites. You have crawled the data, so it may be a text data. Your input may be text data, maybe product reviews, right? It may be audio data, speech data. It may be a signal data. It may be data received from some of the sensors, right? So data means, so data may be of any variety, right? So you have variety of data, right? So starting from sequence data to maybe image data and video data, right? So then you have some machine, some model. So you can say some algorithm which basically process the data. Just excuse me, just. So you have some models. So given a data, so data is given to you, and now the questions. So there are a lot of questions, right? So given a data, you have many questions in your mind that given a data, what is to perform, right? What should be done with this data, right? So because having data, if you don't have problem, so what problem you want to solve, want to basically resolve using this data. If you don't have any problem, then there is no use of anything, right? So data is with you, so you just store the data in any form. But given the data, so if you see that can we solve some of the problem using this data? Can we see that can we predict, can we develop some system which can do some future inferencing, some future prediction using this data? So whenever these questions comes in mind that can we use this data in order to predict the future things, then the first question comes in the mind that what sort of problem we would like to solve. So problem is what type of inferencing, what type of prediction basically we want to basically do to perform from this model, from the approach, from the solution that we would like to solve. So the first thing is the data, the second thing is the problem, and problem that you want to solve. So that is based on the inferencing, what type of inferencing, what type of prediction you would like to solve, would like to perform. For example, suppose you say that you have a data from weather, you have a data from maybe satellite data for the clouds, and all other parameters like cloud parameters, and where the clouds are accumulated, and what is the pressure, air pressure, what is the wind speed. So all the data, all the features you have, properties of the data you have, maybe images you have. So from satellite you have images. Now can you, given those images, satellite images, can you tell that where the heavy rain will be there? So can you do weather forecasting, right? So given a satellite image, given a base data that is received from the satellites, can you predict the weather, right? Weather status, or you can say the weather forecasting. Can we use that data? So whenever this comes into mind, so this is the problem, that weather forecasting is the problem. So given a data, you have to develop some algorithm, mathematical process, so some algorithm which can basically try to tell you that the status of the weather, right? So that is basically weather forecasting model. So for the same way, you have a, suppose you in the medical domain, suppose you have an image, maybe X-ray image is shown to you, and you are not a doctor, you are not an expert, right? So, but given the X-ray, can you, so we would like to basically tell the report, or you can say we want to generate the report, even we are not expert, right? So can you develop a system, can you develop a model, given this set of X-rays, which can generate the report, or you can say which can basically inference, or you can so, give you the status of any disease, or it can say that whether a particular disease is present, positive or negative, right? So there are a lot of problems. So given a data, you have to think about the problem. Once the problem comes into mind, you just try to develop some algorithm which will basically solve the problem, which can basically for the when so solve the problem, and whenever some future data comes, so it will try to inference, it will try to infer the status, or it will try to infer the prediction, right? Infer the output. So that's the usage of learning process. So you have to develop your, so learning is nothing, so the model is nothing, so that is some mathematical algorithm, some algorithm which basically some set of steps, or a set of rules that will basically define the model. Maybe mathematical expressions, very complex mathematical expressions, basically going to define your model. So the model is like this. You have to provide some input. So once input is provided to the model, it will give you the output, and the output that it will generate. So based on that output, you have to take action. You have to perform action, some action. Right? So that's the idea of the model, or you can say the learning model. So learning is basically the process in which it infers the pattern from the data. So you have algorithm. Suppose you have a very simple algorithm, and suppose your problem is that given an image, or you can say given an object, maybe apple, and let your model is doing the classification, right? So classification means given a categories, given a group of classes, so your model should try to basically predict or infer into one of these classes, or you can say one or more of those classes. So based on the type of the classification, so we have different basically problems, right? So suppose you have a problem, so simple binary class problem, so where you have a apples set of images which basically do the apples, so and set of images where you have a banana, right? So you have a two set of images. So one is basically set of basically apples, different apples, and the second set is basically the set of bananas. And now you have to develop a model, develop an algorithm, so which can tell you that given an image, so it will just tell you that the image contains apple or it contains banana. So that's the simple problem, very simple problem. So now the question comes, what will you do with this data? So, and what type of approach you will write so that your model will be able to tell you that the given image contains apple or it contains banana. So what we will do, so you have image, so image may be of any form, right? So maybe you have taken images from the camera, maybe low resolution camera, few images you have with high resolution camera, and different so sources, from different sources you have got the images. So what will you do first? So given an image, you have to think about the features, right? So what are the features which basically discriminate between the apple and banana, right? So as a human, so what are the features we basically perceive, we basically look for in order to discriminate apple and banana, right? Maybe someone may think that maybe color, maybe shape features like maybe height, width, right? So maybe you have a 5-6 features, and maybe someone will say, no, 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 given an image, all the pixels we would like to use as a feature. Of course, you can do that as well. Now the what should be your algorithm? So your algorithm should be like that. So it should basically use those features in order to build a complex function, right? So such that whenever some input comes to that function, the function gives you output. But please note down, I'm saying I have used the word function here. So function has some property, right? So in function, if you have a uh, input, right? So let some input is there. So the output that you will get corresponding to the input. So that so given a two same input, right? Given a two same input, the output that you will get, so that should be same. So that's the definition of function. Otherwise, what will happen? The definition of the function will violate. So the same thing is here. So given some input, data input, if your data input is same, your model should give the same answer. Otherwise, your model will not be perfect, right? So it will be ambiguous, right? So you will not be able to decide, because at some point of time it will say something, at another point of time it will say something, right? So your model looks like a function. So it is a function. Of course, it is a function. Mathematically, if you define the machine learning model or AI model, so they are functions. So they are very complex functions. So wherever you just put input to that function, it will give you the output. So here we call it model. So basically in the AI field or machine learning field, even in deep learning, so we generally call it model, right? So that function that we deduce, that we basically found, infer from, or you can say learn from the data, so that is called model. And once model is learned, you just provide the real data. So you just see in the figure here. So once your model is learned somehow, you just provide the real data. It will be fed to the model, and model will be able to answer you. So model means you can say that this is a function. So if provide input to the function, it will give you the output. So once it will give the output, so based on the output, you can decide what you have to do, right? So suppose you have a medical data, and so given a image, maybe X-ray image. So suppose X-ray image, and your model is just predicting whether the particular X-ray image has the COVID-19 positive or COVID-19 negative. So just simple classification problem. Then your model will tell you that whether the image, X-ray image, has COVID-19 positive or it's negative. So once this is the prediction, and based on the no prediction, you have to just define the action plan, or you can say the medication plan, right? So that's the idea of the learning process. So one diagram here is Venn diagram, if you see here. So that basically defines the AI, machine learning, and deep learning. So this is basically the evolution, that how the machine learning evolves, how the deep learning evolves, initially from AI, right? So AI is a big umbrella, and you know that AI can earlier few decades ago, if you see about the AI, so fuzzy logic systems and rule-based systems were very prominent, and logic-based systems, right, were very prominent in AI, right? Search heuristics, many things are there. Then some statistical machine learning came into picture. So here you have a linear regression and some regression models like ANOVA and ANCOVA and many others. Then later on, the field becomes very, very huge, and it evolves to the machine learning, right? So from statistical learning, it evolves to the machine learning, and now nowadays machine learning we have, and in the machine learning we have few of the models, or few of the architectures is basically exploit the very deep layer architectures, and we call them deep learning. So the base model, mostly people use the neural network in order to basically define the many layers architecture. So deep layer architecture, that is called deep learning. So basically the whole area, if someone says that what is a, so we are working in the area of AI, by the way, whether you are doing machine learning, whether you're doing deep learning, maybe reinforcement learning. So any type of learning we are doing, so we are doing under the umbrella of AI, right? So AI is a very broader term. So AI is the complete umbrella. So where any sort of learning is involved, any sort of intelligence decision making is involved, right? So that is AI, right? Then we have a machine learning, then deep learning. So inside that, so these are the subfield, or you can say the few algorithms we have so that come under the machine learning, but AI is a completely very big thing, right? So I think, do we have any question till now? Am I audible to all of you? Hello.
Yes, sir.
Yeah. Am I audible? Yeah. So is there any question till now?
No, sir. Thank you.
Yeah. So this is a very intuitive slide. So that's why I put here, and this defines the learning process in others. Okay. So now in the next slide, so we have the steps. So we have already discussed that you have a data. So once data you have, then like human, we basically look into some of the features which basically defines the data, or you can say some sort of that, or human model, human brain basically learns about the data. Not data, even you can say the object. So suppose we met three people in a day, and you have basically go through the phases, and you have discussed a few things, and you have basically devoted some time with the person, right? So maybe later on, after 10 days, 20 days, maybe after a year, if you again encounter the visit, or you can say the face of that particular person, so you will your brain will try to infer that somehow we have seen somewhere else, somewhere this particular person, right? So that's the idea. So some of the features basically your brain is basically learning from the object, any of the object, right? So the same thing is here. So given a data, so once data is there, so because we are going to do a mathematical model, so mathematical processing. So the first step is we have to clean the data. So many times your data may have noise, right? For example, images, if we are talking about the images, so many times you may have some blurry images, many times you may have low resolution images, right? Maybe some filtering people have done on the data, so the data is now maybe not looking good. So some sort of data cleaning, some noise removal, maybe some sort of pixels or background you want to remove from the data. So data cleaning is there. Once you have cleaned the data, then you have to prepare the data for analysis, right? So sometimes people do feature extraction. If you are confident that these many features will be sufficient in order to discriminate, basically discriminate among the patterns of different patterns, right, for prediction. So you can extract those features from the data, and then you just try to develop your mathematical model, learning model, which can do the future inferencing, or you can say prediction in the future if real data comes. So sometimes your data may have missing value as well. So can you so missing value is a very challenging problem nowadays as well. So there is no 100%, or uh, you can say the very good approach which can do the missing value. So generally people impute the values. Sometime for missing value people put the 0 if missing value is missing. Sometimes people say that okay, they just do some statistics, like they find the mean and variance, and accordingly they sample the missing value, impute that value there. But all these things are not the 100% right, because so this happens when the data is very number of samples are very small, right? So if your data is very small, then missing value creation is a very challenging problem, and even imputing the value either using the mean variance or either using the simple impute, so that is a very challenging task. So sometimes people do some learning also in order to get the missing value, right? So sometimes they basically discard those samples where you have missing values of the features, right? So there are many ways to basically curate it, but of course this is a challenging task, and you have a lot of scope in order to do research in this direction if you are doing the missing value, treating the missing value. Then once your data is, you have curated the data, your data is completely pre-processed in some sense. You can represent your data in vector space. So here you can say that the dimensions in that vector space is the features. So mostly this is the general way, but you can represent your data in other way as well. So in the first, or you can say the popular way is that, or normal way or standard way is that your data is represented in feature space, right? So this vector is you can say the vector representation of a feature, and your data is represented in feature space. So where each dimension in the space is feature, right? So suppose you have a two-dimension data, right? You have a data which has only two features. So you can represent in simply in XY coordinate, where you can say that X coordinate is the feature 1, represent feature 1, and Y coordinate represent feature 2, right? So likewise, if you have three features, you can go to the XYZ system. So here you can say that X represents the first feature, Y represents the second feature, and Z represents the third feature. So likewise, suppose you have more than three features, then visualization is not very easy, but you can represent your data in 4 dimension. So here 4 dimension represents the fourth feature. Likewise, your data may have 1 million dimensions. So likewise, you can represent your data in 1 million coordinate system, or you can say 1 million dimensions. So that is basically vector space representation. So your data is completely in a vector form. So each feature has the same length vector. So or in other way, you can say that each sample has the values for the features. So sometimes the values may be 0. So so many values may be 0. So we have to represent our data in sparse format. So most of the time our data is in sparse format, and most of the algorithms basically allow the sparse input in sparse representation, right? So so that is basically vector space representation. Then sometime if sample you have a small number of samples, you can augment your data. So augmentation is again we are just somehow treating the problem of some learning problem, because you have heard a word that machine learning models are data hungry, right? So you can prove it. So based on the some learning models and learning hypothesis. So that is basically the PAC hypothesis, probably approximate correct learning. So you can see that based on the generalization accuracy, based on the generalization error, the number of samples, so they are related. So based on the error, right, our tolerance, or basically number of samples are related, right? So sometimes it is quadratic, inverse quadratic. Sometimes it is basically linear to that. So based on the problem, based on the learning models, right? But of course, you need a huge amount of data, and even in huge amount of data. So if you're all the data, some data redundant, or you can say that noisy, so they are not useful. So we need data such that it basically captures the complete distribution of the data, right? So I think if people have somehow modeled any distribution, right? So suppose you have to model the Gaussian distribution, right? And you have only 10 values. So 10 random values you have, and someone say that, can you infer that whether this follows the Gaussian distribution or simply the uniform distribution or some different sort of distribution? So can you tell? So given a 10 points, can you tell that whether these 10 random points are inferred or sampled from Gaussian, uniform, or any other distribution? So that will be a challenging task, and you may not be able to give a correct answer. But somehow, suppose I say that you have 1 million such samples. Now, can you tell that whether the data came from some distribution, Gaussian distribution or not? Maybe uniform distribution, maybe some different distribution. So once the number of samples are very large, you will see that the number of samples, or you can say samples, are able to basically represent that distribution, right? You can just plot it, and you will see that you will get a Gaussian form, or you can say Gaussian plot. So you can see that, okay, if your number of samples are very large, the probability distribution of the values in the features, or you can say the distribution of the data you have captured, right, whole distribution. So it is not necessary that you always need a huge amount of data. So sometimes a small amount of data is sufficient if it is able to basically capture, or you can say represent whole distribution, right? So that is basically, we generally call it the good data. So where your data basically somehow captures, or you can say represents the complete distribution. So that particular set of data is called the good data. And generally in machine learning, people use good data, and sometimes people say that bad data. So bad data means you have a noisy things, and you are not able to eliminate the noise and in the data, and even humans are not able to correctly classify, or you can say your gold classifier base type classifier, or human is not able to discriminate, or you can say infer the prediction, right? So that is sometimes people call it bad data. So you have to remove those bad data also from the data, but that identification of the bad data is a very, very challenging task. And maybe sometime during the learning, after the model development, or you can say you have developed the model and you are doing inferencing. So based on some of the parameters that you will learn, so you will be able to have some intuition about the data, that your data is good or bad. So we will discuss those things in a moment, right? So that is sometimes we can call it data bias. So uh, maybe your data is such that data is, maybe suppose you want to basically discriminate between the apple and banana, and some image that you have, so they are totally blurry images, right? So humans are not able to identify whether the particular image contains apple or banana. Then your model will not be able to basically extract the good features from that data as well, right? So and your model will not perform well. So those type of problems basically come from the data. So your data is biased, right? So data is biased towards something, right? Maybe it is biased towards some of the noise, or maybe it is biased towards something, right? Some of the features. Then of course, after the data cleaning, you have a machine learning model, and you can after training it, after learning it, you can do inferencing, right? And these are the few sources, basically social media sources. You can get the text data, you can get the video data, you can get the image data. So nowadays you can say data is, you have data in enormous amount of data, social media data, right? But only the challenge here again, if you face if we say that where is the challenge, right? So in medical domain, of course, nowadays also we have challenge. So there are many reasons why do we have challenge. Basically in the medical data, the availability of medical data. So most of the time the anonymity clause is the challenging thing. So many places we don't have anonymity models which basically anonymize the data and then they can produce it in the public. So due to the privacy issue, digitization of many hospitals, or you can say laboratories, is not available, right? Even in the current scenario. So there are very few. But if you see, right, there are many places where you can get a few of the publicly available data sets in medical domain, and you can start inferencing. So medical things is basically mostly due to the privacy clause, privacy issue. The hospitals do not release basically the data in public domain, right? So if data is not available, data is not with you, and then I think you cannot do research, right? You cannot do something, right? Some advancement in that prediction or inferencing process. So first thing is the data. So data you of course need. So, but in case of social media platforms, for example, Facebook, Twitter, Instagram, right? Maybe academics blogs like LinkedIn and maybe Academia do. So there are many places where you can get the data, enormous amount of data, and you can do inferencing, maybe product development, maybe something. And even nowadays in medical domain also we have some publicly available data. So they are also in maybe some sort of sufficient amount, but in medical domain you cannot say that we have enormous amount of data available, right? Even nowadays if we talk about the COVID-19 also, so suppose you want to just get some x-ray data, right? So you cannot get any library, any place, publicly available place, even for India and for many countries, where you can get the x-ray data, right? And with labeled x-ray data, right? So where some doctor has certified it, some labeled it, that whether this particular x-ray is COVID-19 or not. So, but there are some publicly available data sets where you may have some thousands, few thousands of samples, maybe 10,000, 20,000, 30,000 samples, and people are trying to build model. But of course, I have already discussed that the machine learning models are data hungry, good data. So if you don't have good data, then number of maybe you have a 10,000 samples, 20,000 samples, so they are of no use. Your model is of no use in real time. So that's the challenge. Okay. So this is the basically data generation model. from user perspective, that why do we have a huge amount of data and why the security is a concern. So you just see here. So as a human, we are basically we are involved in the process of generation of the data. So early in the morning, we wake up and we just try to text, we just try to see some WhatsApp messages, and accordingly we would like to respond, right? So every user who is basically connected with the digital platform nowadays, and the social media platform, so we are generating the data, and so that's the reason that everyone is participating in the generation of the data, and we have enormous amount of data on the social media platform, right? So we hope that in future, maybe your hospitals, maybe medical peoples, or you can say medical institutions, will try to maybe come together, and the similar architecture they can develop, and in order to develop the data, generate the data, right? So then I think there may be a good research, there may be better models which can do the prediction. Only the thing is the privacy. So privacy is here also the concern. If you see here, in user-centric model of data generation, the privacy is a major concern, right? So even we are chatting, we are installing some app, and we are doing something, right, on our handheld devices. So data, our keystrokes basically are whatever we are typing, whatever we are listening, whatever we are basically doing. So that is basically recorded on the social media platforms. So on their clouds or on their databases, so whatever activity we are performing, so they are recording it, right? In some sense, they are storing it. So that's the concern, that's the privacy concern. So whenever you install some app, right, on your mobile phone or on any system, so it asks that certain permissions. So it will say that it will be going to view your media files, right? So media files, and you have to give some access to basically to your system, to your mobile phone, so that they can write something, because you have to install it. So they will say that they want to write on your something on your phone, right? So once you give right access to the apps or applications that you are basically installing on your handheld devices, so privacy is lost, right? Now the question is that privacy, your privacy is in the hand of the third party, right? And now the third party, it's up to the basically the laws or the rules and the policies, if they follow. So whether they will further distribute your information, your private information, your basically user behavior, your basically working behavior to the other parties or not. So that's the major concern. So sometimes they people allow, so generally the user allows the apps to basically read and write their systems, their files, but user do not
Excuse me,
allow.
Balram Timendeji, please off your camera.
Yeah. So is there some question?
No, sir. Please continue.
Yeah. So here you see that this is the user privacy. So we are connected with the many social media platforms, and all these social media platforms basically record our activities, right? Even whatever application we are installing our system, so silently they are basically capturing our behavior, our working behavior, our navigation behavior on the handheld devices, and sometimes silently they may. So there are few basically threats also. So in the recent, even I can say, you can say 1 year or 2 year back, if you go, so Alexa, I think you have heard about the news of the Alexa. So Alexa was basically silently recording all the communications happening, even in the home, right? So even you have turned it off, basically, right? So you are not doing anything with the Alexa. Alexa is basically silently recording all the things, and it was sending the data to the servers, right? So so this is the case for many of the applications, so that we call basically malware in the system. So sometime our systems or OS, whatever OS we are having, some security systems, software that we have in our handheld devices. So sometimes they are able to identify, sometimes they are not able to identify. Sometimes they behave like a zero-day attack. So zero-day attack means attack is happened, and now your system is able to identify. So there are many things, many type of attacks people basically try to do with the system. But the major challenge here is attack is one thing. So Another thing is the privacy, right? So as a user, privacy is a major concern. So who is basically going to use your data? So you have heard the name of Cambridge Analytica during the Gujarat election and many other election, right? Even in during the US election. So we have heard about that uh, Cambridge Analytica, who is basically going to use. So they are using the user privacy, right? User data, user information in order to basically drive the campaign, right? Election campaign, or you can say the political parties campaign. So that's the challenge. And even if any of the system, any of the set of institution, if they are coming together and they are trying to basically publicize, they are going to have some public platform, open platform. So these type of challenges may come into picture. So one, in case of hospital data or medical data, so anonymity is the major concern. So how will you anonymize the data, and so that you can preserve the privacy of a patient, or you can say the person whose data you are going to use in basically put in the public. Okay. So this is the case, and I will tell you that there exists machine learning model which can basically decode your data. So suppose you have a model, and some model you have learned, and you are using that model for inferencing. So there are ways in machine learning, there are some attacks which can basically generate the data from your model, right? So they will tell you that on which data your model was trained, right? So this is a very major security breach in order to basically decode your model or in order to basically attack on your model. So this is the user-centric basically purview of data generation. And then there is a model-centric purview of data generation. So that I have already told you that you have a model. So can you develop a model now? So can you develop a learning model which can generate the data of some sort of distribution, right? So that's the model-centric view of data generation. So many times we generally use it in order to augment the data. So GAN is one of the popular way in deep learning in order to basically generate the data of the similar distribution as the input you have, or the samples that you have in a small amount. So so with that particular so distribution, in that distribution you have to generate the data, you have to sample it, right? So there are some standard way where we have already discussed that you can just say you can sample the data using the mean and variance, and you just assume some sort of distribution. You can assume that the data came from the Gaussian distributions, or you can say that data came from some uniform distributions, or set of uniform distributions, set of Gaussian distributions, set of different distributions. So those were basically standard, or you can say the traditional way. But in the learning models, so nowadays learning models are also capable of generating the data. So we have deep layered architecture, like you have original autoencoders, so they are able to generate the data. They are basically try to basically somehow get the information about the variance and mean and variance, latent variables. And then there is another model called GAN, Generative Adversarial Neural Network, where you have trained your model, and now given the model, can you generate the data? Can you tell that whether this model has been generated, has been developed, discriminative model has been developed from this data or not? So these models can be used to exploit the basically exploit the security of the models also, and they can be used to enhance the model security as well. So in both the ways you can use the learning process. So either you can use it for destroy the system, you can use it for attacking the system, and you can also use it for making the defensive system. So you know that so the learning model are basically the playing the game in some sense, right? So if you want it for defensive mechanism, you can use it for defensive mechanism. If you want to do attack, you can use it for attack as well. So these are the challenges in the data. We have already discussed that noises, multimodality, human bias, right? So during the learning, so basically what are the challenges? So noise, I have already discussed that may come from the different sources. Suppose you have different cameras, and you are getting the video feeds, or you are getting the some images from those cameras, and some camera may have source noise. So all the images that has been generated from the particular camera have some noise, right? So that is basically noise from the sources. Maybe multimodality, you have data, you have created your data and downloaded your data from let you can say from social media sites, and you have some real data you have captured from your mobile phone or handheld devices. So that is basically multimodality. So data you can call it multimodal data. So from different sources you have basically generated the data. Different types of data you may have. So maybe in addition to the video data, you have a text description about the data, metadata you have, right? So data may be a mixture of all the things, all variety of data. So, and sometimes you have a data and you want to label it. So in order to give the expert decision, so suppose you have a data and you have labeled it, some human error may be there. So that you can call it human bias, right? And data, that a lot of data that comes from the IoT, sometimes you have a lot of noise. So maybe for a few period of time, you did not receive any signal, any sample from the data, right? So from the source, right? So that is the few of the challenges in the data. Then even in all the fields, right? Even whether it is medical field, whether it is simply normal computer vision field, social media, whether it is natural language processing, right? Speech processing, right? So everywhere you have the challenges in the data, right? So getting a basically good data, curated data is a very challenging task, right? So I'm just going to give you one example here about the challenges in data. So sometimes you have a very good model and everything is good, your model is trained, and the data that you are using, so on that data it is basically giving you the basically good result, or you can say the good prediction. And now you want to deploy it in the real time, and whenever it comes to the real time, it is performing very poor, right? So generalization accuracy, or you can say in real time, the accuracy is very poor. So what are the possibilities? So the possibilities, so there are many possibilities. You can think about the model perspective, that you have not learned a good model. Another problem may be from the data side. So your data may be some sort of problematic, some noisy data. So in data also there is another challenge also. So maybe sometime your data is good, right? You don't have any problem with the data, but something is available in the data, some sort of bias is present in the data. So I have already discussed that maybe your data is biased towards some of the features available in the data. So that is basically driving the learning process. So for example, here you see the images that we have. So the first set of images, COVID-19. So the model is basically doing the prediction between the three classes. So whether given an X-ray image is COVID positive image, or it is simply the normal image, or it is the image is basically, or you can say the X-ray is infected with the pneumonia, right? Simple viral infections. So and your model is basically, you just see the distribution of these histogram distribution here. So they have completely different histograms. So there is a hope that you can come up with a good model which can discriminate between these two. Only the thing here, you just see the overlapping thing. If you see here, for the for the COVID, right? So COVID image is basically overlapping towards this. So this COVID is here. So this third one is the COVID. The first one is basically the normal one. The middle one that is overlapping is the pneumonia one. So that is basically infected from the viral. So you have to develop some model which can basically discriminate among these three things. So we have a model which can, which is basically doing perfectly good things. But only the challenge here is the model has learned, in order to predict the person, the X-ray image is COVID positive or not. It just tried to, so here some pattern as the corner is there. So some point is, some dot is there. So this was the reason that the camera from, or you can say the X-ray machine where from where you have got the images, basically received the images. So they have some spot on that system, so that it put some spot. So that is a spot from the source. Please note down. So from the source of the data, and that particular spot is basically used as a feature here, and model learns that feature, because all the COVID images has that spot, single spot on the corner of it, edge of the images. You just see here, gradient visualization, you just see here. At the corner, you just see here, for the COVID images, right? You just see here. So there is a very, very good feature, very prominent feature here at the corner, right? So that is just noisy feature, you just see here, but your data has that, and your model has basically learned that feature. So whenever the image comes for COVID-19 positive image comes from the some of the source, and that feature is basically learned by the model, and the other normal images are basically downloaded from the some different sources, maybe from other public websites, public places, and they have trained the model. You just see here. So for COVID-19, it is not looking the pattern of the COVID in the image, but it is just biased to data is biased towards some of the feature that is that came maybe to using the source, or some problem with the source, or some noise in the source. And you will see that your model is saying that your validation loss is okay, very small, or you can say validation error is very small. But whenever you deploy in the real time, so the image came from different source, a different X-ray machine, a different X-ray image you have, so it performs poorly because it has not learned anything. It is basically too biased towards the corner features, or you can say the boundary features, simply the boundary features. So it basically did not look about the pattern inside the image, but it learned the feature which is just some sort of boundary feature, or you can say the noisy feature, right? So this is basically bias in the data. So you may have a bias in the data. How can you get that bias in the data? So you have to, in order to reduce, in order to get the information of the biasing of the data, you have to just go through with the data, and you have to basically download the data or get the data from different sources, not a single source. Maybe single source may have some noise and source based noise, and data, even your data is good, right? So but due to the source noise, your data is basically become has bias towards the learning process. And next one is basically the gene. So simply this is one of the problem, gene expression data. So there are a lot of processes involved in order to basically get the numerical values, or you can say numerical, or you can say vector representation of the data. So starting from the raw data, from the raw sample to this, you can see the right hand side matrix, right? So this is basically the now vector space representation in some sense, or you can say the data now. And in order to get these values in the data, the cell values that we have here, the feature values, so a lot of processes are involved. So during this process, you may have some of the devices may have some problem, some bias, some noise, and maybe during the process, maybe some human error may be there, some human based bias may be there. So a lot of challenges are there during the processing of the data. And now you have a data, and based on this data, and the data has some problem, and with that data we are training the model, right? So you know that if your data is not good, so if data is bad and your model has learned some of the biased feature, right, or the feature on which your data is biased, then in real time, or you can say the generalization accuracy will be very poor, right, in real time. So that's the reason, in order to assess the machine learning model, so generally people split the data into three parts. So training, validation, and testing. And testing is kept outside. So basically, in my opinion, the testing data should be basically representative of the distribution in some sense, and that should basically give you the accuracy based on that. So validation error, the distribution of the validation and distribution of the testing should be similar, right? So that will be the trick, and that will tell you that whether the model is performing good or bad on the real time. And try to have test data or validation data which basically represents the real time scenario in some sense. These are the types of the data. So we have already discussed the data, like variety of data like images, videos, text, signal, speech, and others. So there are some form of the data, you can say some sort of data representation in some sense. So actually the data that we generally get from the social media sources, so they are in the raw form, right? And then after the receiving the data, you have a lot of cleaning and data pre-processing process, pre-processing thing. So that is basically unstructured data. So you just see the second one here. So the data is mostly the data that we have is unstructured form. So text data, audio data, image data, and video form. So that is unstructured. And after cleaning, after representing the data in a tabular form, or you can say in the feature vector form, so data becomes structured one, right? And most of the machine learning model, basically even deep learning models, basically works on the structured data. So where your data is represented in vector space, right? For example, so unstructured data. So how can you define the data is structured or unstructured? So simply the thing is, we have we can tell you the analogy, or you can use it in the databases. So in databases we have relational databases. We have tables, right? So relational relations, you can say, or you can say the tables where you have the data. So in the relations, what we have, so you have a tuples, right? And you have attributes. So each tuple has the value for all the attributes, right? So in the databases, I'm just telling you that suppose the columns represent the attributes, the rows represent the tuples, and each tuple has the values for each of the attribute in that particular table. So whenever some query is performed, so suppose you want to perform some query that maybe some maybe employee database is there, employee table is there, and you have employee name, you have employee age, employee department, you have a other attributes, right? And suppose I say that, can you find out the name of the employees whose age is greater than, who are basically 35 years old or more than 35 years old? So what will you do there? So you will go to the column age column, age attribute, and you will see that how many basically values are row indexes, tuple indexes are there which has value greater than or equal to 35, right? And you will directly display the name of those employees. But what will happen if your data is unstructured? So that is basically case where data is structured. So whenever it is unstructured, so your data is in text form, so it is not in the tabular form. You don't know that at which place what attribute is stored for a particular employee. So what will you do? So you have to basically scan the complete data, right? So you have to scan the complete data, and then maybe one pass, two pass, three pass, maybe more than one pass may be required in order to basically get the answer for the query. So that is the task, that is the way you can do searching. So that is basically searching, right? Only the linear search you can do. So in text data, so you can perform the linear search. So that is not structured. So in audio, the same thing. So if you say that, okay, can you tell me that at what point of time someone said something? So you have to go through linearly, you have to go through the audio. The same thing is basically with the images and the video. But only the thing is that a little bit structured in images and video is that if you have a same resolution image, right? If you have same resolution image, then you can say that each pixel is one of the dimension, or you can say the feature, and you can represent data simply you can represent the data in vector space. So some sort of structure is there, but if you talk about any query, right? If you want to do some query, right? Even again, image and video both fails. So so they are not in the vector space directly in the vector space representation. So they are unstructured form. And if your data is in simply in vector space representation, or they follow the relationship of tuple and attributes. So attributes basically correspond to the features, and tuple correspond to the samples, or you can say the rows or data samples or data points. Then there are some data which is basically called semi-structured. So maybe some sort of data you have that is structured way, represented in a structured way, where you have a tuples, you have attributes, or you can see you have samples and the corresponding features, feature vector you have. And but there are a lot of data which is basically unstructured way. So sometime you have a maybe code multimodal data where you have a maybe structured data, you have a text data also, you have a basically speech data also. So sometimes we have I can give you one example like image captioning, right? So given an image, can you write some story about the image, right? So your data will contain both the things. So training data will contain, in case of supervised learning, so it will contain the image, it will contain the story about that image. And now your model, you have to learn a model which can basically learn the features, learn the patterns, such that whenever input you will provide an input image, your model should tell you the story about the image. So that's the image captioning problem, or story writing through images. So recently, I think you have heard a news that some group at IIT Jodhpur, so they have developed, uh, I think given some story writing. So they have developed some video, right, of the comics, right, where you have a small few characters and few sort of actions there. So they tried to model. So given a story, given a story or plot, so they try to basically develop a visual, or you can say the model videos from that particular thing. So they developed a model, machine learning model, deep learning model, which basically generate the videos. Given a text, they can generate the videos. So this is a basically challenging task. Many organizations are basically working on this. So image to text, text to image, video to text, video to image, video to text, and text to videos, right? So in any case, you know that our models are basically taking care of, so they need structured data in some sense. So sometimes images and videos we are feeding to our deep learning models. So only the thing is that there are models which there are two type of feature extraction, good feature extraction. One is basically explicit feature extraction. So generally people we generally, based on your domain expertise, you can extract the features. So for example, I have given one example of apple and banana classification. So in apple and banana classification, you may extract the good features, maybe you can say the color features, safe features, like maybe height and width, right? Maybe 3-4 features, you just say that okay, these are discriminative features, and you just extract from these 4 features and you can build your model. There are some intrinsic feature extraction. So most of the deep learning, or you can say the neural network based approaches, deep learning approaches, so they try to extract the good features, or you can say the features during the learning process. So there are in the deep layer architectures, the few layers we dedicate towards the feature extraction, and then we basically do the learning. Okay, so two type of feature extraction is, one is implicit, the other one is explicit. In explicit, basically you should know the domain information, you should know the basically feature, what are the good features, what are the bad features. But this is basically a little bit challenging task if you are not a domain expert. If you are a data scientist, you may not be knowing that which one is the good feature and which one is the bad feature. So that's why the deep learning basically is very helpful. So where we do not need to extract the features a priori, but suppose you have something in mind and you have extracted few features, so then you have not to worry. Deep learning model, you can fed those features also. So externally extracted feature also you can fed into the deep learning model. It is not restricting you that it will extract the features on its own. So it will try to extract features on its own, but if you have a good features with you, so you can supply it to the model in addition to the features that the model is going to extract. So there are a lot of basically architectures, framework where you can do this in the deep learning. Okay. So we have already discussed the unstructured data, semi-structured. So sometimes semi-structured data, I have already told you that partially structured. So maybe few sort of things is structured. For example, here in the case of the third just block you just see. So suppose here you have some address field, and address may be a text field completely. You have it written in text form. So in any of the order, so no order is preserved. So that's the idea of unstructured sense. So your data is, something is structured and something is unstructured. So tagging, if you see here, is a structured way, but the information, the content that you will put inside these tags, it may be unstructured way, right? So this is one of the example, but you may have a different sort of semi-structured data. And this is the structured data. So we have already discussed that relational tables where you have features. So each column is a feature here. So in relational databases, you can call it attributes. And Now this in machine learning, or you can say in learning, we generally say that these are the features, and you can represent your data in these features or in these feature vector spaces, right? In these feature spaces. So finally, the take from here is that you have unstructured data. Then sometime you can do feature extraction, internal or external. So sometimes your model is basically capable of doing that. So unstructured data, then data cleaning is there. So we have not written that thing here. So data cleaning, machine value curation, data augmentation. And once you have done that, then you can do the feature extraction, maybe uh, externally explicit feature extraction or implicit. So if you are motivated towards the implicit feature extraction, then you have to directly use the model. So you just represent your data in vector space representation. So for example, in image data and video data, we have already told you that if you talk about the pixel level, pixel as a feature, so each pixel as a feature, as a dimension, then you can directly supply, you can represent your input to the vector space representation, and you can directly supply to the models, right? So so these are the we have few examples here for representing your data, unstructured data, to vector space. So suppose you have a DNA structure, RNA structure, a protein structure. You can represent your data in using the nucleotide sequences, and just say that okay, you have a 20 nucleotides, and accordingly for protein data, so you can say that whenever you can index it, and complete sequence you can represent using the 20 values, right? So for example, text data also, the bag of word model is a very popular model. So one hot vector representation is one of the representation for text data. Image data, so you have a pixel level. We have already discussed that you can say that pixel level representation you can do. You can do some feature extraction that I have already discussed, that maybe shape type of features like color, maybe height and width. So these type of features, maybe texture features you can get from the images, right? So a lot of things you can do. You can do external feature extraction, and sometimes if you do not want to do external feature extraction, you can just supply some of the models, some learning model which can do the feature extraction. For example, CNN for image data. So CNN and CNN based architectures, mostly they basically try to find out the age features, right? Then speech and audio signal, you can do some feature extraction, or you can say that based on the sampling rate of the signal or the audio or the speech that you have received. So you just try to find out the few of the features. So from these data sets, and externally and internally both you can do. So in all the cases, right? So these are the way you can represent your data from unstructured to structured. So up to here, I think many of you have got the information about the data and challenges in the data, right? So is there any question till now? What is the time? Yeah. So is there any question till now? Am I audible?
Yes, sir, you are audible.
Yeah. So is there any question till now? So little bit, this is simply the machine learning stuff I'm just discussed here. So I'm just trying to build the story about the attacks that we are going to discuss in maybe after a few of the slides, right? So that you can be directly able to basically relate the things. Okay. So these are the few problem types that basically machine learning nowadays is basically solving. So there are many more. So these are the few sort of problems we have put here. So classification, you know that this is a very popular one. So classification type of problems are very popular even in your security system. So these are the very popular basically problem type, the classification. So disease diagnosis, drug target identification, drug design, drug discovery, microbial species prediction, environmental and host phenotypes prediction. So maybe protein interaction prediction. So these are the popular classification problems in medical domain or bioinformatics, you can say. Then in network, you have a intrusion detection, anomaly detection, spam detection, sentiment analysis, right, about any product or reviews. Then emotion classification, right, about any sort of object or entity. Can you tell the emotion of the users, or maybe you can say consumers, right? And security system also, can you say, tell that can you design a defensive system? So those are the other type of problems can be do using the machine learning. So we will discuss those things in a moment. So then there are type of regression problems where you can do the efficacy prediction. So given a, suppose you have a wireless sensor network, and can you tell the efficacy about your network? What sort of problems, what are sort of attacks your model is, what is the score of your goodness score of your network system? So you can define that. Maybe other problems in various domains like rankings, translation, maybe document summarization. So in NLP domain, so a lot of problems are there. So that can be solved using this machine learning. So I have already discussed that image to text, text to image, video to text, right? Text to videos. So can we do those things also? So there are a lot of problems where wherever learning is involved. So you can define the problem and you can think of some sort of learning. You can use the machine learning approaches, the AI based approaches, right? Maybe even game theory also. So in game also we need we can deploy the AI based approaches, learning approaches, right? So in nutshell, the learning is of two types. It is basically three types, but broadly it is two types. One is the supervised learning. So the learning model that we have, so that use the information about the label of the data, right? So for example, you have a classification problem. So whatever training data you have, so the data on which you want to learn your model, so that is called the training data. So that training data has a supervised information. So supervised information is called the label information. So the problem that you want to solve, so based on that problem, your data should be have the supervised information. So for example, apple and banana classification problem. So each image that you have in the training should have the label information that whether this image contains apple or the image contains banana. So if this is available, so this is basically called the label. So label is basically apple, or the label is banana. So corresponding to images, corresponding to the samples, if label information is available, and that label information is used in order to learn the model, in order to develop the model, in order to design the model, then your learning method is learning algorithm is called supervised learning. So this is very important that how can you classify your learning algorithm as supervised or maybe unsupervised. So if your learning model is using the label information or supervised information that is available with the data, then your model, or you can say the algorithm, is called supervised learning. And the data, if data has the label information, the data is called supervised data. So two things. One is data is supervised if it has the label information. The second thing is if that label information is used in order to develop the model, in order to learn the model. So that is called supervised learning algorithm. Right? So there are many places where there are many algorithms where we do not use the label information. So if your algorithm is not using the label information, so machine learning algorithm or the learning algorithm, it is not using the label information, that is called unsupervised learning algorithm. Even your data may have label information. So your data may have label information, but learning model is not using that label information in order to infer the pattern or in order to develop the model, in order to get the model. So that is called unsupervised learning. And accordingly, your data, you can name the data. So if data has the label information, you can say that data is supervised data. If data does not have label information, you can say that is unsupervised data. And then once you have trained your model, so now your model is with you. So either you have used the supervised learning or you have used the unsupervised learning. So now your model is ready. Once your model is ready, you can deploy it in the real time. So now the new data comes. So accordingly, sometime you can extract the features if your model is capable of extracting implicitly. So you have not to worry about this step. Feature extraction is not needed. So you can just deploy model in real time. You just give the input, your model will give you the labels. So that is the output. So this is called the prediction, by the way. So this is the supervised sense of learning, and many of you may be knowing it. This is the unsupervised sense of learning. So where algorithm do not require the label information. So mostly, if you have heard, if you are aware of the clustering algorithms, and many times in network intrusion or anomaly detection, so lot of attacks in order, because the attacks are not very so if you talk about the data, and suppose you have some crawl the log information from the some of the networks. So in that log, so normal logs are very in very large number of so you can get the large number of samples for the normal logs, and for the attacks you may get a very few, right? So that's the reason this is very challenging task. Identifying the attack is a very little bit challenging task. The reason is that if you are developing a machine learning model, and you have a data, suppose you have a classification model simply. So whether you have a given data, and you have just tell that whether given this log, can you tell that whether the attack is there or not, some attack is performed or attack is done or not. So what will you do? So because there are very few number of samples, please see here, I would like to relate this thing with the medical domain. So in medical domain also, the positive samples are very, very small, right? But the normal samples, the data with normal samples, or you can say with the negative diseases, or you can say with normal sample, are very huge, right? So the same thing is here. So the attacks are very few if you crawl any log file. So given this scenario that number of samples in one of the class, or you can say the one of the group, is very, very, very few, very, very small, and they are very few. But in other case, in the normal case, they are in huge amount. So this problem is called the data imbalance problem. So we generally face in the network attacks, network security, data imbalance. So generally people do the anomaly detection. So where they say that, okay, so they just try to learn the normal distribution of the normal data that you have. So normal behavior of the system. And whenever some abnormality is there, so they will try to basically detect that using the anomaly detection systems. So there are some algorithms, there are some models which do the anomaly, and even using the deep learning approaches, you can learn the anomalies. But that is a challenging task. So there are some models which basically try to balance the data first. So once you have balanced the data, and now you can just try to deploy many of the machine learning algorithms and even the deep learning algorithms, right? So this is one of the challenges I have told you, discussed here, just informed you that the data imbalance is one of the problem that generally happen in the security domain. And sometimes the data scarcity is there. So sometimes you want a model which can be incremental. So suppose in order to avoid the zero-day attack sense, so suppose you are streaming some data, and your network is basically maintaining the log. So based on the log behavior, so can you try to tell maybe it instantly that your model you are basically getting some threat or not, or your model is attacked or not. So generally the systems that we have, so they are a little bit just once attack is happened, right? So when attack is happened, they try to scan it, they try to find it that some attack was happened, some attack is done, some threat was done. But the question here is similar to the disease in the medical domain. What happens if some disease occurred, right? Suppose you have an X-ray image and COVID-19 has been occurred, right? So if your model is just trained for detecting the COVID-19 positive or COVID-19 negative, so given an image, X-ray image, it will just tell you whether the COVID-19 is there or not. It will not tell you the status, or you can state that whether the person is basically in a day or two it's going to be infected with COVID-19. It will not tell you the progression, or it cannot tell you the status. So there is a there is a need, right? So there is a need to develop a system, defensive system. So defensive system is that system that before the attack, and you are able to basically defense your system. So that's the strategy nowadays people are exploiting. So after once attack is happened, and then you are doing some remedies, you are doing some, you are getting the information that attack is happened. Now you are basically curating that, you performing some curation. So that is already, there's a lot of systems are there that are doing this thing. So only the thing here is I'm insisting that uh, if you are doing research, so you can start research in the direction that can you develop a defensive system. So, and maybe it can give you the alert before the attack. So that's the challenging part, by the way. So that is not so easy, by the way. Okay, but of course you can just try to build a defensive system, good defensive system, which can basically prohibit the system with many of the threats, many of the attacks, right? And these are the few algorithms, machine learning, standard machine learning algorithms, and deep learning approaches basically be generally used in machine learning. So I'm not going into that detail. So another challenge is basically I want to just tell you, I think we can stop maybe 1 or 2 minutes, and then we can stop, and for maybe 10 or 15 minutes, then we can start the next part of that, applications of ML in security, right? So just 1 or 2 minutes here. So challenges in learning. So many times you have model, maybe people are using in security as well, and many places people are using the model as a black box, right? So you have not to worry much. You are not basically much worried about the model. What is the model? So what you do, you have a data, and you have a lot of algorithms, lot of packages, lot of models available. You just feed your data, your data is trained, learn the model, and you can just use the inference, do the prediction. But there are a lot of problems with the model. So which model you have to choose, and you should know that what sort of pattern this particular model is learning, right? So this is a very so if you are not a domain expert, or if you are not a basically data science expert or machine learning expert, so many times you may be confused, may not be handled to this task. So you will try maybe 10 models, 12 models. So you have started from linear regression, then you have the logistic regression, then you have tested on Bayes classifier, then you have tested on maybe naive Bayes, right, in Bayesian. So you have tested on support vector machine, then you have deployed random forest, then you have deployed neural network, and then you have deployed the deep learning, some of the simple deep learning models, and you have got some accuracy, some validation errors, some testing errors, or generalization error. And if you say that, okay, the model which gives you the low generalization error, or you can say the low validation error, you will say that this model is good. And the model which are basically giving the high error and validation data, or you can say the validation data, so they are not good, they are bad models. But there are a lot of things that you have to, in order to declare any model is bad or good, so you have to assess the model in a very deep details. Otherwise, sometimes what happens, there are two things in every model. So in most of the models, right? So there are two things. One is basically the learning parameters. So there are few parameters basically which are basically based on the data, you have to learn it. The algorithm that you will write, optimization algorithm that you will write, so those algorithms will try to learn those parameters. And there are many parameters which are basically called the hyperparameters. So they are not basically parameters which are basically learned by the model optimization process that you are using the learning parameters. So they are hyperparameters, and hyperparameters mostly set by the humans, set by the programmer. And there are some heuristic based approaches where you can just try to get those value of those parameters, but that basically take a lot of time in order to get the good set of parameters. So hyperparameter is a very challenging task. So that is called tuning of parameters. Many of you basically have heard the term tuning parameters. So for any model, so exhaustive tuning is a very challenging task. So you cannot say that this model is good or this model is bad unless until you have just fine-tune the parameters. As you can see, you have tuned the hyperparameters. So in order to assess the model performance, you have to tune the hyperparameters for all the models, and then you have to look three type of errors. One is the basically training error. The second one is the validation error, and third one is the test error. So you have splitted your data into three parts. So in order to basically assess the model, in order to compare the model. So the training error basically, if your training error is very small, so training error is very small, that your model is fitting well or learning well on the training data, and let your validation error is high. So training error is small, but validation error is high. So it means that your model is basically fitting your trained data. So the data that it basically looks in order to get the parameters, so it learns it well. But whenever it comes to the testing part, or you can say validation part, or in real time, or generation, are in real time, so it is performing very poorly. So this particular problem is called overfitting. So variance in the prediction is very high. So this is called the overfitting problem. So there are many ways you can basically reduce the overfitting. You can do the regularization. You can you can do the regularization. You can reduce the model complexity in some sense. Number of iterations, maybe you can reduce. Right. So the number of samples, maybe in training you can increase. In validation also you can increase the number of samples. The second problem that comes whenever your training error is very high but validation error is less, so it means that your model is not fitting well the data. So your training error is very high. So it means your model is not able to learn the parameters, not able to infer the good distributive features from the data. So that is called the bias error. So that is I'm talking about here the model bias. So there are two type of we have discussed the data bias earlier. So data bias may come from the sources. So the X-ray image that we have shown that the corner or boundary features was basically learned by the model. So that is basically from the source. Data can get the bias from the source. So that is data bias. But here I am talking about the model bias. So the algorithm bias. So your model may give you the high training error, but low maybe validation error accordingly. So in order to basically cure, or in order to basically improve that model, what you have to do, you have to go for the complex model. So idea here is, so this is just a trade-off, right, between the overfitting and underfitting. So you just increase the complexity of the model, right? So increase the complexity of the model, it will try to reduce the error. It will try to basically somehow fit the data, right? And it will move towards the overfitting, right? So if you increase the model complexity, it will move towards the reduce the training error, and it will try to basically increase the validation error. So there is a basically trade-off between this underfitting and overfitting. So you have to choose such a model which has low overfitting, or you can say low bias and low variance. So that's the basically choosing a model. In order to choose any model, in order to improve any model, so we have to take care of these two things: variance problem and bias problem, or you can say overfitting and underfitting. So there are many ways. So in underfitting, if your model is underfitting, it means your training error is very high. So your model is suffering from the bias problem. You just try to increase the complexity. So suppose you have a one layer deep layer neural network. Now you can increase 2 layer, 3 layer, number of units you can increase. Maybe you have a linear model, learning the linear model. Now you can start learning the non-linear models, right? In SBMs, or maybe if you are using random forest, so instead of maybe 10 trees, you can use maybe 20 trees, 30 trees, and so on. So you just try to increase the complexity of the model. So number of parameters, learning parameters. Right. So that's the basically way choose the model. And in order to solve the problem, so many of the problems, so we have already discussed that how can you solve it, but many problems will be solved regarding the model if you are able to explain that what the model is doing, right? What sort of patterns the model has learned. So if you are able to do this, if you have some strategy, if you are able to identify from the learned model, so the model that you have learned, if you know that what sort of features, distributive features it is basically it has learned, what parameters it has learned. So that comes under the explainable AI. So if you are able to explain that what sort of prediction it is doing and why this is doing this, right, then a lot of problems, a lot of things, challenges that we have discussed here, like data bias, like model bias, so you will be able to know. Right. So that's a very important field and current state of art in the AI domain. So that is explainable AI, right? So most of you have heard this term, explainable AI. Even this is very important in the security domain, that threat identification. So if you are able to, suppose you have a model which basically do the anomaly detection or intrusion detection, and the model that you have learned, so if you are able to explain that model, that what sort of features it's basically learning or pattern it is learning in order to detect whether the sample or whether the basically whatever input is there, so it is a threat or not. So if you are able to do that, then you can have a good system, right? So you know that what sort of features, what sort of basically patterns, complex patterns it basically look in order to detect the intrusion, right? And you can develop your system, defensive system accordingly, so that the intrusion cannot happen, or you can basically avoid, or you can say reduce the threat. So I think we can stop here, and we can have take a break, and before the break we can do some maybe QA, question answers. Yeah. Yeah, please. Yeah.
Participants, if you have any query, please put it in the chat box.
I think I think there is no question. So there are two things. Other everyone understood the thing.
Okay. We can take a break of 10 minutes, sir.
Yeah. So we can again be here at 12. I think 12:20 or 12:15. So I think it's 12:07 right now.
Okay.
Yeah. So we can be again back here in 10 minutes, right?
Okay.
Yeah. So please write a question, maybe QA at any point of time. Right. We will try to discuss. So it should be more discussion oriented, not a simple just lecture thing. So we will try to make it more interactive, maybe the next session. So that we are going to discuss, right? Okay. Thank you everyone. So we are just taking a break for 10 minutes.